but AI native chips is really where sci-fi comes real. And so today I'm sitting down with someone who's really leading the forefront of that.
Hi, my name is John Koeter. I'm Senior Vice President with Synopsys, and I'm responsible for our IP group, which is elements of design that companies put into larger SoCs to manufacture the chips.
Welcome to GenAI Talks.
You know, we are really at the beginning of this journey with AI. We have so much left to unpack, to deliver. You know, AI is not just changing what we build, it's changing how we build it. One of the next big revolutions in design is what we call re-engineering engineering. Our entire workflows are going to be re-engineered, brought down to the absolute studs and rebuilt here. We're going to have autonomous agents that are going to be designing big portions of the chips for you. And we're just in the very, very early days of that. We have a 5-step model at Synopsys. We call it L1 through L5. Today, we're more like on the L1 stage, L2 stage, right? You know, we'll get to L5, and that'll be like chips. Agent AI will be developing chips for us, or at least large portions of chips for us.
That is immaculate. When you think about the challenge, I think there was a video one time online that showed like how small these chips are, like the orders of magnitude. This is the equivalent of creation of pyramids in our time. Like these are like novel works. And to take that further, what you're describing with this L1, L2, can you get maybe something that people don't know about when they think about chips that again might be important to understand in this, what's coming and how it's evolving so rapidly?
Oh, yes, absolutely. So what we're seeing is we're at a major inflection point in terms of design. What has happened historically, the chip world since the 60s has been doubling the number of transistors on a chip every 18 months to 24 months. You've probably heard of Moore's Law, right? Moore's Law is slowing down. There's another law called Dennard scaling, which is also plateauing. And so what's happening is that the amount of transistors you can cost effectively put onto a chip is changing. Those things are plateauing, they're slowing. And so what we need is a whole new wave of innovation to deal with that, and we're seeing it. We're seeing multi-chip designs. We're talking about very sophisticated packaging, and that calls directly into the need for very complex modeling of these multiple chips working together. It used to be, I'll give you an analogy that a large chip was 800 millimeters squared. That's the biggest chip that a company can manufacture. Now what we're seeing is individual functions that are 10 times that. I mean, it's extraordinary the pace of innovation that's going on in the industry.
What this world is like when we have this level of sophistication in AI-assisted creation.
Yeah, and I also want to take maybe a bit of a contrarian view. There are some people that will say like, well, AI is going to replace all these engineers and stuff. I actually don't see it that way. I actually see that agent engineers, is what we call them at Synopsys, are actually going to complement human engineers. You're going to marry human innovation with machine precision. And that is going to create and unlock an incredible new era of innovation over the next decade.
You wanted to challenge people. You want to put some little contrarian view. So I want to double click. What is something that most people don't know about what's going on right now, or just generally missing about this moment in AI chip development?
Agentic AI is going to change the fundamental way that we design chips. Is fundamentally going to change. And as a result of that, everyone is going to have to completely re-engineer their processes. And I can tell you that's going to create tremendous disruption in the market. There's going to be people, I tell my own team, I'm like, there's going to be two types of people in this world. It's going to be the people that lean in hard to agentic AI, and there's going to be dodos and dinosaurs. You're in either one of those two camps. And because this will disrupt everything.
Yeah, and I think there's so much to that is just inspiring. I mean, you can be on the doom and gloom, but be inspired to be a part of that population that leans in. And there's so many industries to lean in on. So even if you're in your own space of biology, there's an area of that to lean in on. Yeah. If you're a student right now here at Stanford and you're working on some project, lean in. Yeah. This is the time. Yeah. I think there's something that we all see here. Mm-hmm. There's gonna be change. Regardless of how it shakes out, we're gonna see change. If you wanted to speak to anyone that just is out there now working on something, we talked about leaning in, is there any other advice you give to someone to let them prepare for this new world where AI is able to really facilitate this opportunity?
Lean on and embrace your human ingenuity. That's the thing that's going to consistently differentiate you across your career, right? That's the one thing that will never be able to be easily replaced by AI, at least for the foreseeable future. Lean in on your ingenuity, embrace your creative side. Let your mind think of the possibilities. That would be my advice.
Brilliant advice. Ladies and gentlemen, this is the end of our session. But John, how can people follow you? How can people stay in tune with the company?
Well, go to synopsys.com and you'll get a whole wealth of information on the company.
Big ideas, real tools, bold moves. That's what GenAI Talks is all about. Don't miss what's next. Subscribe and explore more in our GenAI community.